Welcome back to the first afternoon session. I would like to make two announcements. The first is that for our first data management workshop, the proceedings are at the registration desk, so if you are interested, you just can pick one up. It's for free. First, it's hard copy. Yeah. The second announcement is that we would like to make a group photo after the session. So I will remind you after the second invited talk that we maybe gather after the session ended on the stairs, and then there we will make the group photo under the banner. Okay, so then I would like to welcome Arnulf and Christl. Thank you very much, and also please give a short introduction to your person.
Yes. Thank you. I feel honored by the sun. Like, this is great, isn't it? But it'll go away when I talk too long. So, my name is Arnulf Christl, and I'm very sorry that I'm already scheduled for another event, so I have to leave right after my talk. But if you Google for Arnulf Christl, you will find me, because my name is a unique ID, which is pretty cool. But in Germany, usually they put an E in my last name, so it becomes the first name of a woman. So a lot of posts I receive is Mrs. Christl Arnulf, because Arnulf could also be a last name. So I'm almost like Chinese. They always have the first name, last name confusion mixing. So what's my role here? I have no idea. I come from software development. And I know Christian, and he knows me, and he thought, oh, I think you had some good ideas about this, so why not let's get you into this session. So I hope I'm not going to bore you. Usually I have entertaining talks, so this is probably not going to happen. What's this about? This is a presentation about software as an afterthought. So software nowadays for us is something we know, we use every day, we don't think about a lot. But when you look into it, then initially software was something different. At this time, software didn't exist. This is Konrad Zuse. He built the first cupboard-sized computer that had the computing power of a wooden abacus. And then later on they looked like this. They weighed 30 tons and had less computing power than these things, like much less computing power than these things. But at that time nobody really thought about software, but they only thought about hardware. And who of you saw Stanley Kubrick 2001, the film, the movie? Remember this view? This is the computer. And when Stanley Kubrick made this movie, he thought that computers will always be really this big size, and yet you will have to walk into them. So this is why this movie by Stanley Kubrick was really, really good and very thoughtful about how the world is going to develop. He was still thinking in hardware more than in software. Now if you look into the computing centers now, you can still walk in them. So what they thought up has really happened. Except that this is not one computer, but it's like 1,567 little computers all wired together. But in the end, it's just one big thing. Still no software. So tomorrow this is how the computers will look like. But the software doesn't look like this, does it? What does software look like? So in 1958, he was the first to use the term software. There was John W. Tukey. And he was still putting it in quotes because he didn't really know whether you should call this thing that you couldn't touch software. It was really interesting. And these were computers. Like the two women there, those were the computers. You called those women computers because they switched wires in the hardware. So that was the first kind of software. The software were humans. They were just pulling cables. And so in the future, on the verge of artificial intelligence, this is HAL 9000. Why is it called HAL 9000? You know? It's in the alphabet, it's IBM. Who knows IBM? IBM is the biggest software company in the world, consulting and all things. Nowadays they don't do hardware anymore, but at that time it was still like the international company that does the strange thing. So just for a relation to think about later on after this thought, how many people does IBM employ? What do you think?
300,000.
Very good, 300,000, an educated man. So what is IBM? It's not really a big company, is it? How many people work in the German government? 4.2 million? That's big, and that's just one nation. So all these software companies, how many people does Microsoft employ? 70,000? It's nothing. It's a small company. And Esri, that's our domain, like geography and all this, they have barely 5,000. So that's small companies. Why is this? Something's wrong here, and we don't even know, because Microsoft even has like television commercials nowadays. What company with 5,000 people can afford television commercials? They're really expensive. So this relation between hardware and software is something very special about this, and we'll try to find what this is. So the difference is that software is untouchable. It's unbreakable. It does not wear. It does not tear. It's just a virtual non-thing and does not need physical space. Well, maybe on a hard disk like these little bits that are, but doesn't really need any space. And most amazingly, when you share it, it multiplies. It doesn't go away. So it's really different because software is a virtual asset. It's different because it can be duplicated. And I will, because she is so much better than me in explaining this, that I just show you this little tape here. That was the wrong button here. So, that one. So please read this for a second. FBI warning. This comes at the beginning of the videotapes. Do not copy this tape because we're going to lock you up and break you and make evil things to you and be really, really, really mean. So let's have a look at this.
Copying is not theft. Stealing a thing leaves one less left. Copying, it makes one thing more. That's what copying's for. Copying is not theft. If I copy yours, you have it too. One for me and one for you. That's what copies can do. If I steal your bicycle, you have to take the bus. But if I just copy it, there's one for each of us. Making more of a thing. That is what we call copying. Sharing ideas with everyone. That's why copying is fun.
Okay, so this is little. It's 60 seconds, and I think she did a really good job about explaining how different this is. So what we take away from this is that we make a little experiment. All of you, please now do this. Copy a piece of software. Shouldn't be very difficult. You just take a computer, an app, give somebody else a link to the app. They can duplicate it by copying it. Now please duplicate a brick. Doesn't work. Very simple thing. So for software, this was very easy to understand. So the evolution of free software, it started in the early, like those two guys here. You always see they're like Kevin, you know, those beards and little crazy hair. And so Ken Thompson and Dennis Ritchie, they built the origins of Unix in the 70s. At that time, nobody knew what open source is. They didn't know because it didn't exist. Why it didn't exist? It didn't exist because the opposite didn't exist. Imagine a world only men. Would you call them men? No. We only had to put the woo before the men when women came into play. So if there is no need to call something, there was no need to call open source because everything was open source. Software only worked on one specific engine hardware. So people selling the hardware also had to sell the software. They didn't sell it because it would work only on their machine. Why should they sell it? Completely crazy. So then there was an antitrust war. Even then, the US Justice Department noticed that IBM was trying to tie software to hardware. And they weren't allowed to. And then came another antitrust war, and they lost it again. But at the same time, Richard Stallman, another one of those bearded guys, came up and said, oh, we need free software. Because he had a problem that he could only solve if he had access to the software. He had a duplex printer, 2 stories higher up. He was sitting in the basement. And every now and then, that stupid printer got jammed. So all he needed to do was put a little program in this jammed printer that would send him in mail, please go up and check whether this thing is jammed. So he could do this, and at one point the Xerox software producer said, no, we're not going to give you the source code anymore. So he had to walk stairs, and he didn't like that because he's a little overweight. So he started this campaign, and he's still doing it because people still don't understand. So the freedom in free software, and this is what he coded. We're not going into more details, but this is like the basic rules, all you need to understand how free software works. The freedom to run the program, to study how the program works, the freedom to redistribute copies, and the freedom to distribute copies of your modified versions. That's all you need to specify, and then you have open source. So around the same time, the Dark Lord started to ship software with the hardware. You recognize this guy? He's a nice guy, actually. He's not bad, and he earns money, which is also good. But he introduced a whole new culture of not giving away, and that is really a problem. So in the proprietary development model, what you have is proprietary motivation to make money. That's in the top left there. Then you have a market analysis, and then some magic happens, and out comes a software that is being sold to you, which is not the right wording. They don't even sell you the software. They only sell you a temporary right to use it. And after that has expired, you're not allowed to use it anymore. So you don't get anything, just a temporary right to use it. So the open source software development model is a little different. What you have here is that you have a problem, and the software development team solves this problem. They call it to scratch an itch. You have an itch, you scratch it, and out comes a piece of software. Cool. But 600,000 of those software projects, free and open source, are currently on SourceForge, which is one of the big places where you can share this software. And 590,000 are crap. They're never going to be used again, because somebody just scratched an itch. You don't want to use something that somebody else used as a scratch and itch to make your bachelor study or your diploma thesis. You want good software. So you have to differentiate between open source and good software. And good software, not all open source is good software. Some of this open source is really crappy. It's open source because somebody thought maybe somebody can use it eventually. But the primary motivation is to solve a problem, not to make a maximum of money. So the motivation behind making open source software and behind making proprietary software is very different. And where does this bring us? Into license hell. How many software programs do you have on your computer? Estimate, guess. Huh? 50? Who has more? I'd suggest around 1,500. That's including all the services and daemons and so on. On my computer, on this one here, there's 250,000 software programs. Because it's a complicated system. It works nice. As you can see, this is HTML, JavaScript, no PowerPoint. It's a nice presentation. So, but the problem is that all the proprietary vendors, they create their own software license. So, did you read your Microsoft Office software license before you clicked OK? Did you?
Not.
So what shall we do about that? It's not very good. Let's try another one of those ones here from Nina Paley, because she's so cool. Here goes. Oh, wrong one. I'm sorry. This is the right one. Anybody know this already? I've been showing it so often already. A brick. Okay, this is what people tell you. You know, when you rent a video, they have this little video where they see the whole life passes by in like minutes, and well, watch out. How can you avoid this? Like getting into this license hell? It's very simple. Just use open source. Now, end-user license agreements. Oh, I just had this one. So nota bene, notice, if you remember anything of this talk, open source and free software can be used almost synonymously. That's the same thing for our purpose here. Most free software is also used commercially. So please don't say commercial software, because that doesn't exist. You have two kinds of software. It's proprietary, which is owned by a private company, and they don't give away. And it's open source, or free software. And they do give away, and both can be used commercially. I'm a commercial guy. I use software to do my business, and all of it is open source. Now, what do you imagine what Google uses for its search engines, and for the data source, and for the web servers? They use open source exclusively. All the bad guys who are big now do that. That's Facebook, that's Amazon, that's eBay, that's Google. All those guys wouldn't exist if you didn't have open source. We wouldn't even have the internet if there wouldn't be open source. So just keep in mind, the big business in this world is done with open source. But we think, if you're honest, until this talk, you probably thought, oh yeah, open source is those guys in the university with the long hairs, and you know, they do that open source stuff, but the real business is done proprietary, big companies like IBM. No. I had to cut my hair and shave a beard so that people start to believe me, but yeah. So, the opposite of free software licenses are proprietary licenses. And free software is not viral, but a vaccine to protect the user's freedom to use software. You may have heard that the GNU GPL license is viral. It infects other software and destroys business. Crap. The GPL protects your user rights. It's completely the other way around. But why have we been educated thinking that proprietary software is good and open source is something like inferior quality? A simple reason. Because Microsoft have a lot of money, and they make commercials and marketing, and they tell you what you're to believe. And there's only guys like me who are small, don't have 60 billion money in the bank account, and every now and then are able to talk to 80 people. Yeah, that's why proprietary software is well known, and open source is sort of, yeah, but I don't know. Well, let's see. So, let's go to the next topic, which is open data. And open data, what is open data? It's very simple. The very simple, most simplest test that you can do is just answer 3 questions with yes. Can you download it? If you cannot download it, it's not open data. Can you use it forever for whatever you want to use it for? If you can say yes, then it's open data. And do you understand the license without being a lawyer? Then it's open data. if the license is something like 60 pages which refer to another document which has 400 pages, which refers to the European Constitution of whatever, then probably it's not a license that you understand. So these three things, if you can answer them with yes, then it's open data. There is three styles of open data. The first is factual data. You were mentioning it, all the sensors, they're collecting all this data now, and that's factual data. It's just collected data. Then the other one is authoritative data. What could that be? In our geospatial domain, it's for example, the cadastral base map. Who owns which land parcel and to which place? No, it's not like always a physical, it's not like a river that makes the border, but sometimes it's just, yeah, this is it, and we define it. It's authoritative. Somebody said, this is it, and this is it. That's the data. And the third one is thematic data, which is derived. You have the sensors, you have authoritative data, you have a theory, you have algorithms, apply to the data, get something out, which is again data, and that is, I call it thematic data. So that's the three different styles of data. And there is three types of open data. I say three types because until this morning I forgot the fourth point. So I just updated my slide because oh man, I'm now at university, there's scientists there. Oh, I forgot. I simply didn't think about you guys. So for me, this workshop was excellent because I have a new idea now. So what is it? Proprietary data in a freemium model. That's the first one. That's the Google Maps of this world. Google Maps is cool, is it? I use it. Admit it, you also use it. But if you want to have the data, you don't get it. You can only see at the pictures they give you. But the data underneath it, you don't get it. The second is public and government data, and we're currently working on the government to make it transparent and open. And the governments are like, very reluctant because there's lots of conservative movements and people don't want you to know that's what they did with the taxes because maybe, you know, it's not quite exactly what they should have done. So transparency in the government is a difficult topic. And the third is community-driven data. Who has a good example for community-driven open data? You all use it all the time.
Wikipedia, OpenStreetMap.
Wikipedia, OpenStreetMap. I don't know, how many people know OpenStreetMap here? Oh, quite good. Oh, that's good. Very nice. So Wikipedia was the biggest one, I think, the first one that I said when they started in 2004. I said, you're crazy. It won't work. Forget it. It's just not going to work. 2005, at the conference in Frankfurt, I was like, ooh, it does work. This is crazy. And now Wikipedia is something like, it's normal. It's just 10 years. It's nothing. In our geological time space, 10 years is nothing. So, and the fourth one is scientific data. And I believe that scientific data, why do you think I forgot this? That open data, scientific data is open data. Because it's obvious. Nobody would ever have science without open data. It's impossible. How could you do science, like I have no idea, I'm a nerd, but you know, how could you do science where there's a theory, it has to be proven or falsified? So if you have something you want to falsify it, what do you need? You need the data it's based on, and you need the algorithm that has been used to prove the theory, so that you can reproduce it. So there's two very simple requirements for science. First, you have to have access to all the data, and second, you have to have access to the source code of the software that is being used to do the research. Because if the software is in some black box, remember the little black box I showed you, then you don't know what's happening. There could happen anything. Like software, usually there is some time in the software development cycle when there happens some magic. Nobody really knows why it happens. We want to know where this magic happens, because if not, we cannot prove or falsify the scientific thesis. Is this wrong? Did I get this wrong, or is this how it should be? Is it like that? Yeah, well, maybe. Yeah, it should. Yeah. Okay, so if you look at this, open data and innovation, where are we now? I think we're in the chasm. You know this innovation curve, everybody knows it. So there's technology enthusiasts, those are the nerds, they have long fingers, white, they have long hair, they eat pizza and live off coffee, they just sit in the basement, hack all the day. Those guys do innovative stuff, but they don't talk to people. So eventually, they have to find guys like me, show me this stuff and say, this is great. And I say, wow, this really is great. And those are the visionaries. So maybe I'm not a visionary, I'm just a talker, but whatever. So you need those visionaries, and then what happens? The visionaries get bored. They go do some other vision. But the pragmatics, they still didn't get the idea of what you really want to do with this great stuff, how you can do it. So I think right now with open data, we're in this chasm. We're still finding our way. And we're starting to see if DFG is on it, and they are starting to be on it, I'm sure that we're already starting to access the brains of the pragmatics. So all the younger guys here, you will live to see all the open data evolvement. We were just chatting a little earlier, and she said 20 years. My hopes were like 2 years, but you know, there's a factor 10 time scale. I'm always wrong, which qualifies me as a bad visionary, but whatever. So and then you come to the conservatives, and right at the end over there you have the skeptics. With open standards, which was the very, very first thing I looked into 20 years ago, there all the skeptics are now convinced that open standards really make a lot of sense. With open source, I think we're right in the middle between pragmatics and conservatives. Even conservatives are now starting to use open source. But with open data, we're still a little further to the left. So, proprietary data in a freemium model is not free. It's neither gratis nor libre. But public and government data should be freely accessible, unencumbered by legal restrictions, and open for private and commercial use. That's what public government data should be for. Community-driven data we already know. It's like Wikipedia, it's OpenStreetMap. It's collected and maintained by a crowd. Nobody knows who it is. Nobody can control it. It just works. It is clearly licensed. Very important. It is clearly licensed. There's no such thing as an unlicensed Wikipedia. Look into Wikipedia. There is a license to it. But you can still use it for free. This is not a contradiction. It actually helps each other. And derived products can be copyrighted, and data stays open and publicly available. And this is what I added this morning because I thought I have to do something about the scientific guys. So maybe you can correct me if this is wrong, but scientific data is usually considered as public data. I even have a spelling mistake. It's not public, it's public data. This data must also be clearly licensed. Is that right? Did you ever license your scientific data? You should. If you didn't do it, you should license your data. Because if not, nobody can use it. And if you want your name to propagate with your great data, then you should tie your name to the data. This doesn't mean that you don't give it away. You still can give it away, but tie your name to the data. It's good for you, and it's good for everybody who uses it later on. So anybody can prove or falsify a theory based on this data, and can redistribute without any restrictions, except all changes to the data have to be documented, and source and author have to be referenced. Obviously, those two things are important. So, the definition of data, let's switch forward, is from the Open Knowledge Foundation: access, redistribution, reuse, absence of technological restrictions, which can also be that you have a strange format that you publish it in. Something like your thesis shouldn't come in a Word document, because that's not a format. That's crap. It should be an open, standardized format, which Microsoft Word nowadays, well, sort of, a little bit. But you know, there is so much data in Germany from the public government in Word document in a binary format that nowadays the new computers cannot read anymore. That's official public data. Come on. You can't store this in a format that you need to pay for money for the software to be able to read it. There's something wrong there. So, okay, all the rest is self-evident attribution, integrity, no discrimination against persons, groups, fields, endeavors, distribution of license there. And license must not be specific to a package, and license must not restrict the distribution of other works. So, what do? We use the open database license. This is one license. There are several other ones, but this is probably the best one that is currently around. There's a new version just coming out and has just come out. I still have to check what they changed, but this is good. And it just says you are free to share, copy, distribute, and use, produce works from the database, modify, transform, and build upon the database. And as long as you, and there you see, the restrictions is always more than what you're allowed to, even in this kind of license. You must attribute any public use. You must share a lake, so if you make it publicly available, then you must make the results available, then you must make the data also available. And you keep it open. You are not allowed to restrict it. You have to make sure that everybody can read this data. So that's a short summary in a human readable version. We're in a transition from words to icons. We don't want to read anymore, so there's these little icons where you have little bulbs and little hammers, so it's easier to understand. And then you have government open data. I worked in Southampton actually at the Ordnance Survey for half a year trying to help them get this public data there. And they have a pretty good one, which says copy, publish, distribute, and transmit information, adapt information, exploit commercially, and so on. But something's wrong about this license, because it says you're allowed to adapt the information. That means change it, modify it, but it misses a passage where it says you have to document what you did, which is a big problem, because somebody can just take the data, modify it a bit, then make his thesis, prove it with the modified data, and say this is the result. Maybe eventually somebody finds out, but maybe not. So this is actually a little snug in the British version, in the UK version of this license. So, Creative Commons, you might have heard of Creative Commons. There is a CC0, which is the ZC0. It's technically not a license, but is what people can use in other legal systems, like the Anglo-Saxon jurisdictional system, where you have, German word is Allmende, it's the commons. We don't have this in Germany, even although the word is still German. There is no such thing as public domain in our legal system. Yeah, but it doesn't really exist as a concept. If you're the author of a project, of a product of work, then you will be the author for the rest of your life. You cannot detach yourself. For the public domain, you can say, yeah, I did this, but it's not mine anymore. Just take it. Anybody can use anything with it. And all the public government data in the US, for example, has to be public domain. So we have completely different legal systems that are trying to work in a global context, and they don't work. And what currently is happening is that, do you know the German word for copyright? It doesn't exist. There is no such word, therefore we say copyright. So even in our legal system, even in our language, you can see the different legal systems. So the whole topic is really complex, and I have to come to an end. So these are the bad guys. They're like Facebook. How do you pay Facebook? Do you pay Facebook? What is your currency to pay Facebook? Your private data. Exactly. Twitter, Facebook, even eBay and Amazon, they use, on Google Plus, they use your private data to fund their services, which is a cool system. I'm fine if they know my Google search terms, but maybe not everybody is, and most people don't even know that they pay with their private data and their activity on the web. So this is just business. It's okay. But using fear has negative consequences, so we shouldn't be fearing them. And we're working on changing it. So, yeah, this is more like in the context of geospatial data, and then I have more examples on the data. But the important thing is that if we drive home, what actually we need to do is we need to understand the licenses, terms, and conditions that we need to publish our data. Combining licenses can be intricate, but open data has come to stay. So in summary, moving from open standards to open source software, a natural next thing is open data. And a friend of mine a few years ago said, oh yeah, you software guys, you're cool, but you know what? Your software is worth nothing if you don't have any data. So open data is the mission that we're currently on, and that was the finish of my talk. And again, sorry that I'm not available for later afternoon, but you can contact me on Twitter, on Facebook even, on Google+, or through my website, or through email. So if you have more questions, feel free to contact me anytime. Thank you.
Thank you, Arnulf, for your talk. And you see, coming from the area of, let's say, geodata, digital maps, and so forth, open source, open data is discussed for many years now. And there are some examples which now already have an impact on new data missions. The Sentinel European Space Agency missions or new satellite series will be open data because they learn from the Landsat example when they opened the Landsat data publicly available that it produced so much more benefit for employees, so the whole value chain enhanced so much that they hope for Europe this will be the same case. All over the world, and they expect, I think, that it will produce in the next years 200,000 to 300,000 new jobs just by making the data freely available. So that's, I think, is a very good mission. And for me, being a data manager, usually everyone comes to me and wants the spatial data for free. But at the same time, very often they do not want to share their own data. So that's also a very nice experience. So are there any urgent questions to Arnulf? I do not see any, but there is one urgent question.
Well, it's not a question, it's actually a comment. I think it's very important that you, I think it's actually very important that you said, well, there's a plethora of licenses around, and I think one of the major points is now that we enter this area of open data, don't invent licenses of your own. We should come to a very small set of licenses for data, if at all possible.
Okay, thank you very much again, Arnulf.